today I'm gonna run a little experiment, a little game perhaps. I'm gonna be testing nickel strips and see what they can handle. This is not a very scientific experiment, but this is just for me to see how I can improve this setup for more serious testing. I have this discharge tester that can handle 20 amps. I have this battery that can handle 2000 watts, or at least like 35 amps. It's a 14S battery that is slightly discharged. And I have two nickel strips. I decided to go with equally wide, but I do not have overlays. I have the exact same. So this one is 0.1 millimeters thick. One of the thinner ones I have, and this one is 0.15 I use when I build the Shan High-Long case. I have hot glued these two wooden plate. Not very scientific. And I've hot glued the temp sensors underneath here, so they have very good connection, but they're still a little bit hot from the hot glue. I'm just gonna run this one through some tests and see what at least the connections are stronger than the actual nickel, so the most heat will be during this part, and hopefully most in the middle where the temp sensor is. Because it's equally wide, so the temperature should be equal at this part and most in the middle one. Yes, we're gonna use step 1. We're gonna use discharge for 991 minutes. And we're gonna start at 1 amp. So I'm just gonna experiment while I wait for them to cool down. Almost no voltage drop. 27.6, no increase in temperature. Oh, slight increase. Now it's on 2 amps. This one is 27.6. Maybe I broke the temp sensors when I put them into hot glue. That was actually an increase on about... yeah, now it's rising. It's still going up a little bit, so we're gonna stop there. And we're gonna change to the nickel line. Okay, we're almost down to room temperature. Let's say 25, and we're gonna start this one at 2 amp. So the temperature rise on this one is about 1 degree rising. In a real test, I would have solder wires down all the way to the nickel strip, really wait for it to cool down. and I'm not sure this one is accurate because I don't have any good watt meters right now. This one is rising, so I would advise to test wait 2 minutes and see how much it rises. Or wait till we have peak temperature. And these temp sensors are not professional at all. This one seems to be stable now at about 2.3 degrees. Gonna stop that. Gonna switch back to this one. Still, it hasn't reached room temperature yet. But I'm gonna try it with. Let's go up to 5 and see what happens. Surely this should be able to handle 5 amps without getting seriously hot. So we're at 5 amps, battery's doing fine. The temp sensor is a little slow, it only checks like every 2 seconds. But now it's rising faster, much faster. I'm guessing it will land on like 35, so we're just gonna keep checking. And I also devised another experiment. I will capacity test to the same battery twice, one using steel and one using nickel, and see if there's any capacity difference. I can feel there's some temperature in here, so this is not optimal. Now we're up to about 35. I'm gonna write that down. This one is not good at measuring metallic surfaces. It's way better on plastic. Probably wood. The reason is, I don't know if you can see it, but this one reflects the beam up onto the wall, which I think is why this one measures metal so poorly. No, this one is still rising. This one is fever temperature. Yes, on this part it's getting really hot. Here it's a little cooler. This is not a real science experiment, this is just a preview on how I am gonna be able to figure out how to do a good nickel amp testing. So I'm gonna stop it at 40, because it will probably keep rising for a bit slowly. Then I'm gonna go back to the nickel, that it's almost down to room temperature. Off, yes. So I'm gonna start the nickel. It's on, it's at 5 amps. How does it handle 5 amps? Well, not as affected as the steel plate, which is way cooler now. You can't even feel any temperature rise. So first thing I will have to do is get more accurate temp sensors. These are good for like general use, but if you're gonna do a science experiment, you want something that's very accurate. strip should be able to handle at least 10 amps with any real loss. But with a slight temperature rise. Yeah, this kind of experiment will take several hours because I have to wait for it to cool down. Maybe I can build some fans to cool them down to faster between experiments. But with this one seems to be increasing not to 40, but rather stay on 30. Maybe like 32. We're gonna close that one at 31. We will. This one is still not cool down, but we do not have to worry about that. We know that the initial temperature is about 25. So we will do one run with 10 amps and see what kind of temperatures we get. Discharge 15, nope. Yes. And start. Amps. Yeah, it's really hot. It's like 40 degrees over here, so the temp sensors are really slow. Jesus. Now it's smoking over here, so we're gonna stop. Yeah, stainless steel like this really can't handle 10 amps. But we're gonna do the same with this one. It was so hot that it even melted the glue. Gonna see if nickel handles that. Yeah, it's cool now. Yeah, now this one is getting hotter. 40 degrees. I saw this really cool YouTube video yesterday with some guy testing Wago connectors and butt crimps, and he had a 16 AVG wires and he loaded them with 90 amps. The isolation melted and all the connectors still was able to handle his 90 amps. And the wire handled 90 amps even though the silicone has burned to crisp. Not as fatal as the other one. So we're gonna keep going. And I'm gonna use watt meters to verify that we actually have that wattage in the wires close to the nickel. Yeah, it's stabilizing at about 550 degrees, which is way too hot. So this couldn't really handle 10 amps. Well, they can handle it, but there's a little too much heat. It has doubled the temperature now, so we're gonna cut it off. And we're gonna come back in a few weeks with better testing equipment. I think we can use this one at least. And maybe I can think of something better than this old plank. Yeah, this was it for today. Gonna close at 50.